Right. Good evening, everybody. Triple T number 15 is 2017 O level third question, right? Structure this is third means part 2, third question, right? Mainly we have questions from chemistry section. Remember these chemistry sections, right? Whatever which is given here, bonding lesson is given here, and structure of matter, that part is given there, and chemical reactions are also given. These three lessons in chemistry are also very important. Every paper you have a structured essay question from them. Mostly it is the third question. Mostly your third question is made from this section. So learning this section is a very good advantage to you. It's a very good advantage because guaranteed there is a question from these three sections together. And when it comes to structured essay, you know you can't ignore it. Even if it comes to essay question, you can skip it, or you can select some other question which is easy. But this section surely will most of the time come to structured essay section. Therefore, studying this is a very good advantage to you all. Don't worry, we will be doing many triple T's on this section, right? First of all, 2017 paper, third question. To do this section, you surely should know the periodic table, right? Any student to do science, you should surely know what periodic table, right? Don't go to the final exam without knowing the periodic table. Surely you should memorize the periodic table. That's a must. Periodic table, if I write hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, noble gases are right. Potassium, calcium. What are the noble gases? Helium is there, neon is there, argon is there. These are the three noble gases. So periodic table is a must to memorize. So once when you memorize the periodic table, no need to memorize the atomic numbers separately. Using the periodic table, you can say now nitrogen is 7. So atomic number 7. Aluminium is 30. When you count, it's 30. So atomic number 30. Calcium, when you count, it is the 20th element. So atomic number 20. When you count phosphorus is 15th element. So phosphorus atomic number 50. So once when you memorize the periodic table, so many different things that you don't know will start opening up. Another example, when you know the periodic table, you can easily write the electronic configuration of fluorine. How? Periodic table, you know, fluorine is the 9th element. You just count 9th element. Atomic number 9. Atomic number 9 means electronic configuration 2, 7. So using the periodic table, you can discuss, or you can even learn about electronic configuration. Not only that, now next we'll be doing electronics. No, after electronics in our class, we'll be doing electrochemistry. In electrochemistry also, this section is very important, especially when you decide the what you call reactivity of some metals, which is more reactive, which is less reactive, right? So those kinds of discussion also can be done to some extent when you know the periodic table. So learning periodic table is a must when you do science. So here they are talking about group number 2. Group number 2, all the elements belonging to the second period of periodic table are given. So here they have given it also, but not in order. Arrange all the above elements as in periodic table. So once when you arrange the second period, you have lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, but I think almost most of you wrote it, right? Most of you have written it, but some of you made mistakes. These 4 you were able to write. These 4 most of you struggled to write. So see that you all memorize the whole section. Now, so I give marks for some of the people have written these 4 correctly and these 4 in mistake. But remember, sometimes they won't give marks, right? If they ask for the whole section, you need to write the whole section correctly in order, right? So I gave marks for some who wrote these 4 correctly, these 4 in wrong. I gave marks, but see that you all memorize the correct order. So now itself memorize. No time again to memorize. So tell me, second period, what are the elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Again, second period, what are the elements? Lithium, beryllium, boron, carbon, Nitrogen, oxygen, fluorine, neon. Again, second period, what are the elements? Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now tell me, third period, what are the elements? Third period, what are the elements? Sodium, magnesium, aluminium, silicon. Phosphorus, sulfur, chlorine, argon. Again, sodium, magnesium, aluminium, silicon. Phosphorus, sulfur, chlorine, argon. Again, sodium, magnesium, aluminium, silicon. Phosphorus, sulfur, chlorine, argon. Right. Second group, second period memorize, third period memorize. Is there anything to memorize in first period? No. Why? Only hydrogen and helium are there. Is there anything to memorize in fourth period? No. Only potassium and calcium are there. So memorize the second and the third period. And this one, sometimes you get confused. Right? You might think calcium is 19, potassium is 20. If you have that confusion, memorize that also. Right. Roman number 2. Write the electronic configuration of fluorine. Fluorine is going to be 9th element, then atomic number 9. If atomic number is 9, first orbital there are 2 electrons. If 2 electrons are gone, remaining how many electrons are there? 7 electrons are there. 7 electrons in the second orbital. There you go, you have the electronic configuration of fluorine. 2, 7. Third one, question 8. Write the chemical formula of the compound which is formed in the reaction between lithium and oxygen. Lithium and oxygen. Roman number 3. Lithium is in first group. These are first group elements. Lithium is in first group. That means they are metals. Right? Lithium is in first group. First group elements will gain electron or give electron. First group elements will like to gain electrons or give electrons. Gain or give. First group, they like to gain electrons or give electrons. Very good. They like to give electrons. Why do they like to give electrons? Because they have excess electrons in their last orbital. In their last orbital, they have some excess electrons. When they have excess electron, they can't keep it. If they keep it, they become unstable. For example, if you look at sodium atomic number 11, electronic configuration 281. You can see last orbital has excess 1 electron. If they keep this electron with them, they become unstable. So what do they like to do? They like to give out this 1 electron. If they give out this 1 electron, see how many electrons are there in the last orbital? 8 electrons. If 8 electrons are there in the last orbital, then they are stable. If they give an electron, they will gain a positive charge. So remember, first group elements, they like to give electron and get +1 charge. First group elements, they like to give electron and form positive cation. First group elements, they like to give electron and form positive cation. Then what about second group elements? Second group elements have 2 electrons in excess. So for example, if you look at magnesium, 282, that 2 is an excess. They like to release that 2 electron and obtain 2 plus charge. Third group elements like to gain +3 charge. Then people, first group, second group, third group, they like to give off electron. They like to release their electron and become stable. Then people, lithium is in first group. First group, they like to give 1 electron and form lithium +1 ion. +1 ion. What about oxygen? They are talking about lithium oxide. What about oxygen? Oxygen is 6th group element. 6th group elements like to gain electrons. How many electrons they like to gain? 2 electrons. Why? If they gain 2 more electrons, they will come to noble gas configuration. See, 1, 2. When they gain 2 electrons, they will gain noble gas configuration. Noble gas configurations are always stable. Oxygen likes to become stable. Therefore, they will gain 2 electrons and become stable. If oxygen gains 2 electrons, oxygen will form 2 minus charge. Lithium release electron and form +1 charge. Oxygen gains 2 electrons and form 2 minus charge. Now what? They can form a compound. Positively charged ion and negatively charged ion can form a compound. How to write the formula of the compound? Oxidation state is the valency. So oxygen's valency is 2. That 2 is given to lithium. Lithium's valency is 1. That 1 is given to oxygen. 1 you don't need to write, no, so I will see. There you go. This is the formula of the compound form when lithium and oxygen. Then how to easily find this? Very simple. Lithium is first group. Their valency is 1. That 1 is given to oxygen. Oxygen is 6th group. Their valency is 2. That 2 is given to lithium. There you go. You have the formula of lithium oxide. This is third A part. Now B part. What is the type of chemical bond present in the compound statement in A? You can see lithium is forming an ion. Oxygen is forming an ion. Lithium is forming a positive ion. Oxygen is forming a negative ion. Ions, between ions, if a bond is formed, you call it what? Ionic bond. Ionic bonds are formed between positively charged ion and negatively charged. Right? How is covalent now? Here, why positive charge ion is formed? Because lithium has given the electron. It doesn't like the electron. You go. It has released it. It has given it fully. Is that electron belonging to lithium anymore? No. It is given. You can have it. What does oxygen do? It will take those electrons. It will take it and keep it. Those electrons belong to oxygen. Thereafter, those electrons doesn't belong to lithium. It is totally belonging to oxygen. Oxygen has taken the electron. That's why it has formed 2 minus. So lithium has totally given electrons. Oxygen has totally gained electrons. Ionic bonds are. How is covalent bonds formed? Remember, in covalent bonds, electrons are not fully given or electrons are not fully taken. Electrons are shared. I'll give an electron, you also give an electron. My electron doesn't only belong to me, it belongs to you also. Your electron doesn't only belong to you, it belongs to me also. Sharing. So remember, covalent bonds are formed by sharing electron. That electron belongs to both the elements. Ionic bonds are formed by giving and getting electron, not sharing. Giving and getting electron. Those electrons that are given. That doesn't belong to the person who has given it. Okay. So there you go. You have ionic bond between lithium oxide. Always remember, first group metals will always form ionic bonds because they like to form ions too. So they always form ionic bonds. Second group metals also always try to form ionic bonds. They like to form ionic bonds because they like to give their electron. Third group elements also like to always form ionic bonds. Third group also likes to form what? Ionic bonds. Right? About fourth group, you know, carbon-like elements. They like to form covalent bonds. Carbon dioxide, methane, ethane, all are covalent bonds. So remember, first three groups, they are metals. They like to give their electron and form cation, that means positively charged ion. So they always form what? Ionic bonds. Right. Next one. In the given box, draw the Lewis structure of carbon dioxide molecule, which is formed with a combination of carbon and oxygen. Lewis structure of carbon dioxide. First of all, how to draw Lewis diagram? Very easy. What is the shortcut to draw Lewis diagram? This is question number 4. Based on Lewis diagram. Now listen very carefully. The people who are suffering to draw Lewis diagrams. Listen very carefully. What is the shortcut method to draw Lewis diagrams? Very simple. First of all, I will summarize all the Lewis diagrams in our syllabus. There are only 8 Lewis diagrams you need to know in our syllabus. There are 4 diatomic molecules: hydrogen, chlorine, oxygen, can see nitrogen. Only 4 diatomic molecules are there. You can see only 4 diatomic molecules are there. Hydrogen, chlorine, oxygen, nitrogen. And there are 4 heteroatomic molecules. What are the heteroatomic molecules you have? You have water, ammonia, methane, carbon dioxide, CO2. There you go. These are the 8 structures that you should know. These are there in the syllabus that you should know. Other than that, under hydrocarbon section, I will teach some other structures. That is a separate story. But however, in our syllabus, what you should mainly know is this. In hydrocarbon section, you will know some other things based on carbon and hydrogen structures. Then how to draw these structures? Very simple. I'll first draw them in key and then teach all the shortcut method. See, I'll teach with the shortcut method. What you should know to draw Lewis diagrams? You should know the valencies. You should know the valencies of all the elements. If you know the valencies of all the elements, drawing Lewis diagrams are very simple. I will teach you all a shortcut to memorize the Lewis valencies also. Now, some of you tell, sir, it's hard to memorize valencies. I will teach you the shortcut to memorize valencies also. See, group number 1. Whatever the elements you have in group number 1, then what are the elements in group number 1? For that, you need to memorize periodic table. You can't tell, I won't memorize anything. You need to memorize at least one name. So memorize the periodic table and key. Then, in periodic table, what are the first group elements? You have hydrogen. Just keep hydrogen aside, right? Because even though we tell hydrogen is in first group, it's actually out. It's not actually considered as a first group element even. We talk about hydrogen separate. It doesn't belong to any group, any people. So keep hydrogen aside, right? I think in the syllabus book, hydrogen is given as first group. When we are teaching also, we teach as first group. But actually, when you look at the correct periodic table, hydrogen is kept separate. It's not in first group, it's not in first period. We talk about hydrogen separately because its properties are totally different, right? So, however, first group, then leave hydrogen aside. Lithium, sodium, potassium, rubidium, cesium, friendship. Now, other things you don't need to. So, first group, you have lithium, sodium, potassium. Memorize that and keep. First group elements, valencies are 1. Is there anything hard in memorizing it? First group, I'll write it here. First group elements, valency is 1. Very simple. Then what about second group elements? Valency 2. Then what are there in second group? You have, after lithium, what you have? You have beryllium. Then after sodium, what you have? Magnesium. Beryllium and magnesium. Beryllium and magnesium, valency is 2. Third group elements, valency 3. Nothing to memorize. See, first group 1, second group 2, third group 3. Now you all guess enter. Fourth group what? Valency 4. Now be careful. Fifth group, valency is 3. Sixth group, valency is 2. Seventh group, valency is going to be 1. Eighth group, valency is 0. Eighth group, valency is 0. So, group 1, 2, 3, 4, valency is equal to the group number. Valency is equal to the group number. Group 1, 2, 3, 4, valency and group number are equal. But when we talk about group 5, 6, 7, 8, valency is equal to 8 minus group number. Why 8 minus group number? 8 minus 5 is 3. Valency is 3 for group number 5. 8 minus 6 is 2. Valency is 2 for group number 6. 8 minus 7 is 1. Valency is 1 for group 7. 8 minus 8 is 0. Valency is 0 for group 8. That's all. Now you can write the valencies of any element. Then you all tell me, what is the valency of sodium? What is the valency of sodium? Sodium means group 1. Now that you should know. Periodic table you need to memorize and do. What is the valency of sodium? Very good. Valency 1. What is the valency of aluminium? What is the valency of aluminium? What's the valency of aluminium? Aluminium group 3, then valency is very good. 3. Now you all can tell valency of any element. Using this method, you can tell valency of any element. Now, you all tell me what is the valency of hydrogen. Now, hydrogen I told you don't consider here. Remember, valency of hydrogen is 1. Valency of hydrogen is 1 means one hydrogen likes to build one bond. One hydrogen likes to build one bond. There you go. Hydrogen likes to build one bond. Valency 1, hydrogen likes to build one bond. What about chlorine? Chlorine valency 1. That means they like to form what? One bond. There you go. Now, for chlorine, 1 electron is gone for bond. Chlorine is a 7th group element. Then 7 electrons are there in the outermost shell. 1 electron went for bonding means 6 electrons are there around. This chlorine the same. 7th group elements. 7 electrons are there in the outermost shell. 1 electron went for bonding. 6 electrons are there remaining. There you go to the structure of chlorine. Oxygen. What is the valency of oxygen? Oxygen is a 6th group element. Therefore, valency is 2. That means oxygen likes to build 2 bonds. Valency, that number of bonds they like to form. So they are 6 group elements. 6 group elements. So valency is 2. They like to form 2 bonds. 6 group elements means outermost shell 6 electrons are there. 2 electrons went for bonding. Remaining 4 electrons are there. Same oxygen, 6 electrons in the outermost shell. 2 electrons went for bonding. 4 electrons are there. Nitrogen. Nitrogen is a 5th group element. Valency 3. Valency 3 means they like to form 3 bonds. They are 5th group elements. 3 electrons went for bonding. Then 2 electrons are remaining. They are 5th group elements. 3 electrons went for bonding. Then 2 electrons are remaining. If you don't understand, if you can't remember the method how to draw this, memorize these points. Very easy, no? Hydrogen single bond, chlorine single bond. However, 6 electrons are there remaining. Oxygen double bond, 4 electrons are there remaining. Nitrogen triple bond, 2 electrons are there. 2 electrons are there. 2 electrons are there. So don't get confused with this arrow. Huh? Right? Now coming into the next section, ammonia. I erased one, no? Or did I erase? I erased water. I wrote water here separately. Ammonia. When you look at heteroatomic molecules, draw the central atom first. Nitrogen. One element is the central atom. Nitrogen, 3 hydrogen are there. 1, 2, 3. Now look at your valency chart. Nitrogen is a 5th group elements. Valency 3. How many bonds they will like to build? 3 bonds. Valency 3 means they will like to build 3 bonds. These 3 bonds are formed between all the 3 hydrogens. There you go. 1, 2, 3. Next, what you check? How many electrons are remaining? Nitrogen is a 5th group elements. Then outermost shell there are 5 electrons. Out of 5 electrons, 1, 2, 3 electrons went for bonding. 3 electrons went for bonding. Remaining 2 electrons are there. Remaining 2 electrons are there. Right? Remaining 2 electrons are there. Right. Next, coming into methane, CH4. Carbon, 1 carbon is there. So carbon is the central atom. Carbon is the central atom. Again, that problem is there, no? Like last class. Wait. Right. Carbon, CH4, 1 carbon, 4 hydrogen means carbon is the central atom. Then 4 hydrogens are there around. First flowing. 1, 2, 3, 4. Carbon. What's wrong with the Wait a minute.